Hi, and welcome to my presentation, a demo-based introduction to SUSE Cloud Application Platform. My name is Peter Anderson, and I work as an EMEA development and application platform technical strategist. So what I do is actually sit in between marketing, product management, and sales engineering, and try to coordinate technical issues and information around developing the application platform. So this is the agenda for the presentation. Start with a short introduction, a little bit, which I'm right into now. Talk a little bit about the architecture. I'm going to do a demo god ritual, as this presentation is very demo focused. And as everyone that has done demos knows how easy it is that things go in a direction that you don't want to. So I want to please the gods by doing a short ritual there. So then I'm going to start and do a couple of demos. You can see them here. First push, do some changes to it, and do second push, show logs and shell, scaling and auto-healing, and how you can do smooth deployment by using SUSE Cloud Application Platform. And final demo will be stateful apps. And then a short wrap-up where we'll talk a little bit about why we're doing this and the benefits and so on. So, but at first I'm going to start with a little poem, or what do you call it. Cloud Foundry is very boring in the best way possible. You write your code, you push it, and Cloud Foundry does everything else. You don't care about the actual containers or any other details. It just works. So that is what I'm going to show during this demo and this session. So first, I'm going to talk a little bit about the installed architecture. So this is the architecture where we have SUSE Cloud Application at the top. Let's see if I can get my nice pointer working. Yeah, so we have it here, which contains a lot of containers, and it runs on some type of container platform. It could be either a public cloud container platform like Microsoft AKS or from Google or Amazon, or on SUSE CAS or SUSE CAS platform. They could be running either on public cloud or on the virtual machines or on bare metal. But what we're going to focus on during this session is on the top here. In the session, I'm going to be the developer, and I'm going to be using the platform as a developer and demonstrate how you as a developer can benefit from it. The platform consists of 3 or 4 systems. It's 1 master and 3 workers, 27 pods, and as this session was planned to be run remotely during the SUSECON in Dublin, I had planned to have a VPN connection to my home, but I skipped that, so that's why it's in parentheses. I deployed it by using a couple of Helm charts, so I'm going to talk a little bit about that, show what I've done, and using Stratus as the management GUI. I'm going to demonstrate that as well, and also I'm using a service broker using Minikube. So this is basically what you need to do after you have a container platform up and running. Just add a Helm repo and deploy it by using Helm Install. And this is the Helm chart I'm using. So it's very short and easy to install. So this is what I did when I installed it in my home environment. I'm going to show a little bit what it looks like. So move this one out of the way. So if you run kubectl, get nodes, you can see the nodes that I have, 1 master and 3 workers. And if you run kubectl, get pods, -n SCF, you can see the pods I'm using. This is actually the whole environment. And you can see the number of pods by running this. It's 27 pods. This is a big benefit of using the Cloud Application Platform from SUSE, because competitors that deploy a Cloud Foundry solution is normally based on virtual machines. So then you have 20 to up to 40 virtual machines that does the job. But the SUSE solution is running it on top of Kubernetes and running it in containers, which is much more easier and a lower footprint on the system, and therefore more efficient. So what I'm going to do now is to first push and show a little bit how the environment is working. So in my directory here, I have a small Ruby script. You can take a look at it. So this is it. Hi, I'm your first SUSE Cloud Application Platform web app deployed. And so this is a simple Ruby script which I'm going to show how to deploy into a running environment. So running the famous cf push command, and then it starts working. I'm going to show what is actually happening under the hood now. So what I did was running cf push as a developer, so it communicates with the user authorization authentication system to make sure that I was allowed to do this. And as I had logged in, I was allowed to do that, so it zips everything in my directory and sends it up to SUSE Cloud Application Platform, stores it in a blob store, and starts a container. The container analyzed what did I send up in this stage, analyze it, and it finds out, in my case, that it was a Ruby script, and download Buildpacks for Ruby script. So it has a rule set where it goes through what should I do with what things that I sent up. So, and the Buildpacks gives the flexibility, so you can have Buildpacks for different programming languages, in my case, Ruby. It also downloads some dependencies because it contains a couple of frameworks in my code. Builds a droplet, that's the Cloud Foundry version of containers, or container images, if it can be correct. Stores that in a database, information about it, and sends up the droplet to blob store, remove the environment it created here to stage it, remove that, and start the droplet it created, and set up routes to it, and store all of that in the database. So let's see if it worked. So if we go to my environment here, you can see that it seems to be working, and it started, and here it created a path to, so I can access it. HTTPS, HTTP. There it is. So this is the application I just pushed. So to prove that I'm really doing something real, I'm going to modify it a little bit. So let's see if I modify it and add something. Instead of add hi SUSECON, for example. For it, and do a new cf push. There we can see what it's doing. You can see that it staged it and downloading the different build packs, and figure out that it needs a Ruby build pack. Start building it, and download some dependencies, and continue working on it. So that uploads the droplet that I mentioned before, and destroying the staging environment, and start the app. So let's see if it works. See? So I'm not faking. It's the real real. So I changed it to SUSECON here. So in many environments, and this is the benefits of running a true PaaS platform. It starts in many other ways. If you're running it more on a container platform, you have to take care of a lot of infrastructure things. So for example, what many pipelines contains is that you start with the base image, you patch the image, you add some stuff to it, maybe glibc and other things. You might need to connect it to the database, you set up the network connections and so on. All of these stages are actually changed to CF push instead. So you don't need to do all these steps. So that is taken care of by the platform. So that is actually what PaaS is all about, platform as a service. So me here as a developer running CF push and push it to here, and then the user connects to the apps that I pushed. Notice that I'm using star there, which is a wildcard domain. So I'm going to talk a little bit how that is working. So it creates something.cap2.mynet. That is. So what happens is if I do host and look to resolve this name, you get back 10.1179. So if I changed it to something else, .cap2.mynet, it still returns that. So what is happening is actually when I go with my browser to this IP address, the Go router built into the CAP system detects what application do I want to connect to and do that. And do the connection, so it routes it to the right application. So if I, for example, change my address here, use something else, the SUSE Cloud Application Platform does not know how to route to it, so it gives me a route error. So the system contains of a couple of containers. So depending on, I'll start from the beginning. Please cut that. So what we at SUSE has done is taking open source Cloud Foundry and containerized it. So these are what the containers that we can look at. So for example, if we look at the routing, which I mentioned, so this is the part that takes care of the routing. I communicate with the CF command via the APIs, and also stores the blobs internally and so on. The architecture of Cloud Foundry looks like this. So as you can see, it is a very complex, and this is where SUSE provides value. So instead of setting up all these connections and so on, SUSE has done that for you. So you just run the Helm charts and deploy that. So the next thing I'm going to talk about is another demo, and I'm going to talk about logs and shell, because it's very important how to troubleshoot your applications. And logs and shell is very important there. So I have another app called Worker App, which imitates a microservice. So it does not have a route to it. So it's an internal service that just provides some information over APIs, simulates that. If you look at what it is doing, it's doing something simple. It's just an endless loop. So here we have each put some data out on standard output. So just every 5 seconds it writes doing some work on standard output. So we can push that, see what's happening. That is also a Ruby script. So SUSE cap zips it, sends it up to the blob store, SUSE cap analyze it, create a container that stage it, and start building it. So now it's up and running, so we can run the magic command cf apps, see the applications we have pushed, and here we had a web app which I pushed before, and now we have the worker app. And you can see here that it does not have a URL to it. Another way to look at it is in our console named Stratus. Let's see, we have pushed. So here we have the two apps. So we have the worker app here. Look at it a little bit more. Number of instances and routes, it should be empty. Yeah. So one way you can connect to it is by SSH to it. So CF SSH and worker app. What I'm doing now is using the Cloud Foundry APIs and connect to my running container or running droplet. So what I can do now is running ls and ps -ef and other things, normal commands. And if you look at the directory app, you can see that we have the periodic logger here. So when I did the push, this was sent up and created automatically. So this is how you can troubleshoot it. And also if we want to look at the logs, we can run cf logs. So as I mentioned before, every 5 seconds it writes out doing some work on the standard output. I'm going to talk a little bit later on why that is important. And we can also use Stratus, our graphical interface. So for example, if we want to take a look at it, we can go here and run into SSH from the GUI. Same thing here. The filester, and you can also look at the log stream. So this is the logs. You can see here how it ends that up. If we want to look at the total log in the whole environment, so this is the logs from the whole environment where I have. It creates a lot of logs internally. So a lot of stuff is happening inside SUSE Cloud Application Platform right now. So the next thing I want to talk a little bit about is scaling and auto-healing. As we are in the cloud native world, things must be able to scale and handle that. And also, if something goes bad, it should auto-heal. So if something goes bad and crashes, it should start it up again. I'm going to demonstrate that as well. So I have one fancy app called O5 Resilience Imperfect app. Just push that. I'm going to show the source code. Nothing fancy or secret there, but for the demo, it doesn't matter. So now the app named Imperfect App is up and running. CF apps. Come on, let's see it here. And we have one instance of it. So what I can do is scale it. CF scale minus I. 2, or yeah, around 2 instances of it. Shouldn't take the route to it. I should take the app. So now it should work. Yeah. So if we run CF app again, we can see now that it's 2 out of 2. If we go into Stratus and look at our applications, you can see it here as well. And you can see the number of instances here. So 2 of them is running. I can scale them up even further, starting a couple more. So now I have 4 running. Look at it. Yeah. So this app is really simple. What it's doing is actually showing, hi, I'm app instance and the number. That is the instance number. So when I reload the page, it connects me to the different ones. So it is a round-robin algorithm here. This app is quite fancy. It has a crash me button. So what is actually happening when I push that is that that instance will crash. So let's do that. Oh no, I crashed. So now you can see that number 3 is not available. So if I crash a couple of them, more of them, you can see now 0 and 3 is up and running because 3 was restarted. So if I crash all of them, and here you can see that it's automatically detected that it has crashed and restarts them again. So now all of them has crashed. But if I push the reload button, you see app instance 2 is started. And if I push reload a couple more times, the other ones should be up and running soon as well. See? So now all of them is up and running. So you can see the robustness of the system. So Cloud Application Platform detects that a couple of instances is crashed, and it tries to restart them. So that is what I did now. So let's scale this down to, let's only have 1 running. All right. So the next thing I'm going to talk about is what I earlier called smooth deployment or blue-green deployment. So what will try to simulate is that you have one version of an app running, and then you want to test a new version. So you want a small portion of your users using the new versions, and the rest, the big mass of them, will still use the old version. So I will show you how you can very easily do that within the SUSE Cloud Application Platform. We go back to the initial app and modify it a little bit to show that it is version number 1. So version 1. And what I also have is another file called manifest. So the manifest.yaml is the one that is used originally. So that is the one when I just run cf push, this one is used. So it is the name of the app, that it should create a random route, and the memory footprint that that application should have. But what I want to do is using another manifest called mod manifest. So if we take a look at that, mod manifest, change this to version 1, and it can also tell what number of instances, so we can change that to 2, so it immediately spins up 2 instances of that application. And also tell here that it should not use a random route, it should use a route which I have decided. So called smooth_deployment.cat.minet. So to be able to use my modified manifest, I use -f. cf push -f manifest. So it starts that. If we go into Stratus, we can also see that it's deploying. So you can see here that it's not green yet. It started to deploy it. Look at the number of instances. So it's started 2, but they are not up and running yet. Maybe the demo devil hit me. Nope. Now it's up and running. Good. So CF apps. You see the apps. So it has a different name. It has web app _v1 compared to that one instead because they used another manifest. And now it's not using a random URL. It's using one that I've defined that it should use. So this one. Oops. Go to that. HTTP colon slash. So as you can see, now it prints out version 1 here. So what we can do is scale it up, or maybe do it from Stratus instead, scale it up to 4. So the idea now is that I will create a new version of the app. Yeah, config new, change it to number 2, and we add more manifest, and change the name of it to version 2. But I will not change the route to it. That will still be the same. So now I have 2 different apps using the same route. If push -f mod manifest. If we go to Stratus and see what is happening here, you can see that it has version 2 of the app and version 1. If we look at version 1 and the routes to it, you can see that it is smooth_deployment cat2.inet. And if you go to version 2, we have only one. No. Oh, yeah. I have the manifest, so it created 2. So I changed that later on. And has the same route to it. Let's see if it is done. So now I have version 1 and version 2, 4 instances and 2 instances, and they have the same route. So by mistake, I forgot to change the manifest, so I can do it manually afterwards. So what I do is scale minus n, no, minus I, 1, and set. Scale it up and down from the command line or using Stratus, for example. So now I changed it to 1. If I go to it here and look at it, so now as I'm the users that try to connect to this app, and as you can see, almost every time I connect to it, I get to version 1. So out of 5 times, I get to version 1, 4 out of 5. So this way you can control that most of the users get to the old version, but you can smoothly introduce new functionality and so on, and measure how does the user base react on it. This is how many applications are deployed these days, where you introduce it to a couple of users, and if something goes bad and you don't like it, yeah, deploy or take away version 2. But if everything is okay, you can smoothly phase out the version 1. I'm going to show you how you can do that. So now I'll do it from Stratus. You can do it from command line as well. So we look at the number of instances. We have 4 of them here. So if I modify it and changed it to 1, so now I have 1 instance of version 1 and 1 instance of version 2. So now when I connect to it, every second time I get to version 1, and every second time to version 2. And if everyone is happy, yeah, we can remove version 1. So just move it to 0, and yeah, it warns me, are you really sure you want to set the number of instances to 0? So yes, I want to confirm that. So now every time I do reload, I only get to version 2. So, and it's easy to roll back again if it doesn't go the way you expect it to go. So now I have 1 of each again as soon as it has started. Yeah. All right, so that is one way of doing it. So now I turn off. So now I have only version 2. So next thing I'm going to show you is something called a stateful app. And then I'm going to jump into 12-factor app development strategies or processes. When we develop these days using cloud native deployment and development, these are a couple of rules you should follow. It's called 12-factor apps, but these days it has been added, so I think it is up to 16 or 17 factor apps. But if you look at here, you can see that processes should be stateless. So the reason is that if application crashes and the data is gone, or the data should not be gone because you should store it outside the app. You can also look at the logs. I mentioned it before. So all the apps should create logs and use it as an event stream. So every app should create logs, and you send it to a central log server and collect it, and or use the tools I showed you, CF logs. But in real life, when you have a big environment, you probably have it sent to some central logging like Splunk or something else. All right. But what does it mean that the processes should be stateless? Because everyone knows, yeah, you go to Facebook, you have your login credentials and so on. Some states must be there. But what you do is store it externally. You should not store it inside the app. You should store it in something else. So that is what I'm going to show you right now. The tricky thing is that this demo is very hard. So now I'm going to do the demo god ritual. So please beware of me, because I need to make sure that the gods are with me. All right, so hopefully that made the gods happy, and now I will start doing that. So we have one app here called Shared States. That one, a stateful app. So what I will do now is push this app, but I will not start it. And the reason is that I need to connect it to some kind of state database, and I will use Redis. Inside Cloud Foundry, you can use a marketplace. You can use CF Marketplace to see what systems and services can I use and connect to. In my environment, I have done very simple. I just installed Redis, nothing more, and using a mini broker for that. In real production environment, you will probably have a lot of databases. You might have other services like MQ if you deploy it in the cloud, for example, on Azure, and you can connect to Microsoft services there and make sure that they back up and store the data for you. But now I'm going to do a simple application using a simple Redis database. So if I just run the CF services command, you can see that I don't have any services defined. So the next thing I'm going to do is push the app, but not start it. If push, and find there's no start. So the system is initiated, and it makes sure that the app and the routes and everything is created, and some other metadata is created inside the system. So if you run CF apps, you see that, here it is, but it's stopped, so it's not started. Right? So what we'll do now is create service, CF create service. Look at my little paper here. And the name of the service and what version I will use. So 507, I know it should work. And then name it. So I can name it service that is 5-0.7 or whatever. So what is happening now is that Cloud Foundry using some internal communication strategies to communicate to this. So if we run this command, you can see what is happening. So the create is in progress, and if we go to running, you can also actually see it on Kubernetes level that it is starting something. So get pods minus n cube. Cubes, so they'll get namespaces. Broker, sorry, I say mini cube, I mean mini broker. Sorry, mini broker. So here it is. So these two, this one is the actual mini broker, and these two are created now. Still not up and running yet. So waiting for that one to be up and running. Yeah, so now everything should be up and running. So let's see if But Foundry also find it started and ready. So now it is successfully created, but there are no bound apps for this service. So what I need to do now is bind my application to the service. So let's do that. CF bind service, and then the name of the app, stateful app, and the name of the service, which is service Redis 507. What I now is bind them together. So if you run the same command again, you can see now that it has been bound to this app. So now I can start the app, cf start. Okay, let me stay. Look also in Stratus. Here we can see Marketplace. So these are different services that I have defined but not using, just using Redis. And here we can see the actual instance of that that service. Let's see, it's still not running, still doing it, but it's in the final stage. Here's the route to it. Let's connect to it. So see that every time I connect to it, it remembers which instance I'm connecting to and how many times I've touched it, this instance and number of times in total. As I only have one instance, it is the same. So, but what happens when I scale it up? So if we go to instances and start a couple of other instances of it and connect to it. Yeah, so now you see every second time I connect this instance 1 and instance 0. The number in total is increased every time, but it also keeps track of which one I have connected. So the instance 1 I have only touched 7 times, and instance 0 I touched 25 times. And this can be scaled up even further. So this shows how easy it is to connect and using a service broker architecture inside SUSE Cloud Application Platform. So now, when all of them are, so now I have 3 instances. Let's see how they change. Cool, that was the demo part. So, but what I'm going to discuss now a little bit is, yeah, it's a very cool technology, but what's the value? It's quite impressive. First time I saw this, I was very impressed and liked it a lot. But what we can see here is a typical build pipeline. So what we do in an organization is plan, we code, we build it, we test it, we release it, and deploy it and operate. All these steps are necessary, and we have the feedback loop. So every step is done in iterations. But the real important part is the first part. That's where the development department is really productive, where they add value. The rest is some things they need to do, but it does not provide much value. It is a must, but and we call it York shaving. So the idea behind using a PaaS platform is to keeping this part as short as possible, to decrease it as much as possible. So instead of having all these steps that many people are working with these days in a cloud native environment, is to download a base, patch it, and a base image and patch it, and add a lot of steps and build up this, and have tools like Jenkins and other CI/CD pipeline tools, and have a lot of steps and manually script it, or buy it from a vendor where they have scripted it and provided all these tools. Instead of having one tool that does all of this for you and does it in a controlled way, that is the true benefit of using a PaaS platform. And in our case, Cloud Foundry. Another big advantage is also that developers can focus on what they do best, develop, and the operators can focus on what they do best, operate the platform. So the developers are using an application platform, in this case, SUSE Cloud Application Platform, and the operators run it. And to be able to run it, they need SUSE CaaS, or running a cloud-based container service like EKS, GKE, and AKS. And Cloud Foundry has done some investigation of how much time you save. So if you go from a pre-Cloud Foundry solution and go to a Cloud Foundry solution, you can cut down the number of days, how long time it takes to deploy an app. So before they were using Cloud Foundry, about 7% were able to push or run a new version less than a day. After almost 27% was able to do that. And if it take 1 to 6 days, it goes up from like 10% maybe up to 25. So what we're trying to do by using a PaaS platform is moving away from this area up to here, where things goes much faster, much easier to deploy, and speed up the deployment of new versions of your applications. And if you look at what SUSE is doing in the Cloud Foundry world, we are very committed to it. We are a platinum member of Cloud Foundry Foundation. Our platform, Cloud Application Platform, is a certified distribution of Cloud Foundry, and we are leading some of the projects inside Cloud Foundry. So, for example, what I showed you was that everything here runs on top of Kubernetes. SUSE is leading that and running that and heavily involved in that, and also the graphical interface, where I showed you how I can manage it also from a graphical interface called Stratus. That is something that SUSE has created, and we have also give it to Cloud Foundry, and they have accepted it as a part of Cloud Foundry. So now it is totally driven by Cloud Foundry, but SUSE is very heavily involved in that. There is another project called Arena, because when I do a CF push, it is running inside a Diego cell. A Diego cell is actually Cloud Foundry world of containerization. So what will happen when Project Arena is in production ready is that when you do a CF push, it will deploy it as a native Kubernetes container, the app you're running. I gladly show that in another demo if you're interested. And there are probably other sessions at SUSECON where you can look at it. So I finish with a short haiku. Haiku is a Japanese poem where you have 5 words, 7, and then 5 words, 7. Here is my source code. Run it in the cloud for me. I do not care how. So that's what SUSE Cloud Application is all about. Thank you for listening to my session and have a great day. Thank you very much.